A routine node drain just cost you 14 hours of Kafka messages. The team assumed Kubernetes would reschedule pods one at a time, but a deployment has no stable identity. All 3 pods were evicted in parallel, new pods got random names, and the cluster split into 2 controllers. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover Kubernetes StatefulSets. A stateful set is a Kubernetes API object for stateful applications. It guarantees each pod has a deterministic name, its own PVC that follows it across rescheduling, and a predictable creation order. A headless service creates individual DNS records for each pod, enabling peer discovery. Without it, pods have stable names but no resolvable addresses. This is the headless service definition. The key field is cluster IP. None, which tells Kubernetes not to create a virtual IP. The StatefulSet Manifest ties everything together. The service name field must match the headless service, and volume claim templates provision 1 PVC per pod. This is the full StatefulSet Manifest. Notice the volume claim templates section. It creates a PVC named data.io TheCodeForge DB0, data.io TheCodeForge DB1, etc. StatefulSet operations are strictly ordered. Pods are created sequentially and deleted in reverse. Rolling updates start from the highest ordinal to preserve lower ordinal pods. The partition field enables canary deployments. Here, partition, 3 means only pods with ordinal equals 3 are updated. Pods 0, 1, and 2 stay on the old version. PVCs are tied to pod identity. When a pod is deleted, its PVC remains. When you scale down, PVCs for removed pods become orphaned and accumulate cost. This policy controls PVC cleanup. When scaled, retain leaves orphaned PVCs after scale down. Set to delete for automatic cleanup, but only with confirmed backups. A PodDisruptionBudget ensures that during voluntary disruptions like node drains, a minimum number of pods remain available. For a 3-node cluster, set min available. 2 to maintain quorum. This PDB ensures at least 2 pods are available during voluntary disruptions. Kubectl drain respects this and will block if evicting a pod would violate the budget. This is the same issue we highlighted at the start. Here's exactly why that happened. The team used a deployment for Kafka brokers. During a node drain, all 3 pods were evicted in parallel. Without stable identity, 2 brokers simultaneously believed they were the controller, causing split brain and data loss. The fix was to switch from deployment to StatefulSet. The StatefulSet ensures pods are evicted 1 at a time, preserving identity. A PDB with min available, 2 guarantees quorum during drains. PDBs only protect against voluntary disruptions like drains. Node crashes are involuntary and PDBs do nothing. Use pod anti-affinity to spread pods across nodes. This is the exact mistake from the incident. Using a deployment for Kafka means pods are interchangeable, no stable identity. During a drain, all pods can be evicted in parallel, causing split brain. A failing readiness probe on any pod blocks the entire rolling update. The controller waits forever. Always test your probe independently. Scaling down a stateful set does not delete PVCs. Orphaned PVCs accumulate storage costs indefinitely. Always monitor and clean them up. The persistent volume claim retention policy, field shown in the article, is available only from Kubernetes 1.27, stable in 1.29. On older clusters, the field is silently ignored or rejected. Always verify your cluster version before relying on this feature. The article mentions pod management policy, parallel but does not show a concrete example. For stateful workloads that do not require ordered startup, e.g., a distributed cache, set this field to speed up scaling and rollouts. The article warns about orphaned PVCs, but does not emphasize that the StorageClass, reclaim policy, default delete, can cause data loss if a PVC is accidentally deleted. For production databases, set reclaim policy. Retain on the StorageClass to prevent automatic PV deletion. Use these commands to diagnose stateful set issues. Always verify DNS resolution, check for orphaned PVCs, and ensure your PDB is configured correctly. Let's run through some common interview questions. What is a stateful set and when would you use it? For stateful apps needing stable identity, persistent storage, and ordered deployment. How does a headless service differ from a regular service? No virtual IP, creates per pod DNS or records. What happens to PVCs when a stateful set is deleted? PVCs are retained by default. Use retention policy to auto-delete. And a few frequently asked questions. Can I use a deployment for a database? Not recommended. Identity loss can cause split brain. How do I clean up orphaned PVCs? Manually delete or set when scaled. Delete with backups. What is the default pod management policy? Ordered ready, creates pods sequentially. To recap, stateful sets are essential for stateful workloads. Use them with headless services, pod disruption budgets, and careful PVC management to avoid production incidents like the Kafka split brain we saw. Ready to go deeper? Up next, Kubernetes HPA, then Kubernetes monitoring with Prometheus, then Kubernetes architecture explained. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.